In today's lesson, we're going to look at the properties of radicals. And we're going to focus on two properties that you need to memorize when dealing with the square root function. The first one is the multiplication. If you have a square root of some number times the square root of another number, that is the same as taking the square root of the product of those two numbers, a times b. And the division property is if you have the square root of a and you divide by the square root of b, that's the same as the square root of the quotient, a divided by b. For our first example today, let's look at simplifying the following expressions. Say we have the square root of 2, and I'm going to times it by the square root of 17. So looking at property number 1 above, this is the same as taking the square root of 2 times 17. And now we just simply multiply 2 times 17 and get 34. So our answer is the square root of 34. This time we have 4, the square root of 3, quantity squared. So let's distribute that square as we learned in previous sections to get rid of the parentheses. We know that 4 squared is 16. And we know that the square root of 3 squared is the same as the square root of 3 squared, which is square root of 9, which we should know is 3. So I have 16 times 3, which is 48. So that means that 4 the square root of 3 quantity squared is the same as 48. In example 3, we need to remember put our like terms together. So we're going to multiply the numbers outside the radicals together. So that means I have negative 5 times 2. And then I'm going to multiply the numbers under the radical. So that's the square root of 2 times the square root of 7. Now using our new property of multiplication, I can rewrite this as negative 10 times the square root of 2 times 7. Well, 2 times 7 is 14. So my simplified answer would be negative 10 times the square root of 14. For example 4, I'm going to start by distributing my cube to each of my bases here. Or you can also write this as 2 to the square root of 2 times 2 to the square root of 2 times 2 to the square root of 2. So you can either distribute as I did in example 2, or you can rewrite it 3 times as I'm doing in this example. Just like in example 3, now let's put the numbers outside the radical and multiply them together. And then we're going to put the numbers underneath the radical and multiply them. Well, 2 times 2 times 2 times 5 is 8 times 5, which should be 40. Now I can multiply 2 times 2 times 2 times 3 if I wanted to, but I notice I have a perfect square root because 2 times 2 is the square root of 4. So let's just keep those together. And I end up with my final answer, simplified answer, is 80 times the square root of 6. Still using those two properties of radicals, let's try some more examples. The directions again are to simplify. For this example 2, we're going to look at division. So I have the square root of 3 divided by the square root of 27. So remember from our properties from the last page, I could rewrite this as the square root of 3 divided by 27. We always want to simplify first if we can, so I know 3 will go to 3 one time, 3 will go to 27 9 times. And then let's take the square root of each. Well, what's the square root of 1 divided by the square root of 9? Well, we know the square root of 1 is 1, the square root of 9 is 3. So this problem simplifies down to the fraction 1/3. The square root of 50 divided by the square root of 2. So we're going to rewrite this as a fraction underneath the radical. So that's going to be the square root of 50 divided by 2. Well, we know 50 divided by 2 is the same as 25. So this is the square root of 25. Well, we know square root of 25 is 5 because 5 times 5 equals 25. Let's say I have the square root of 81 divided by 144. I could do this two ways. I could first simplify 81 and 144 because I know 9 will go into both of these. And I could rewrite this fraction as 9 over 12. 9 over 16. And then I can break this up. That's the square root of 9 divided by the square root of 16. Square root of 9 is 3. Square root of 16 is 4. Or I could have did the square root first. I could have said the square root of 81 is 9, and the square root of 144 is 12, and then simplified the fraction 9/12 into 3/4. It does not matter if you simplify first or last, but always remember to simplify. What if I gave you a mixed number? So let's say if I asked you to find the square root of 2 and 14/25. First thing you must do is rewrite this rewrite the mixed number as an improper fraction. So I got to take 2 times 25 and add 14, and I'm going to write that 64 over our original denominator of 25. And then we're going to work this problem just like the last one. So I'm going to take the square root of 64, which I happen to know is 8, and I'm going to divide that the square root of 25, which I happen to know is 5, to get a final answer of 8/5. In example 3, sometimes they're going to ask you to write your answer in a certain form. For this one, we're going to write in the form of k times the square root of 3. So I'm going to look at the number underneath the radical, that 432. So since I want 3 on the outside here, let's divide this number by 3, because it has to be divisible by 3 at least once. When I divide it by 3, I get 144. As soon as you recognize a perfect square, you can stop on doing your factor tree. I happen to know that 144 is 12 squared. So I can rewrite this now as 3 times 144, which is the same as 3 times the square root of 144. Square root of 3 is still square root of 3, but 144 square root is 12. And I write this as 12 the square root of 3. Notice because it says k, the square root of 3 form, I need to write my whole number in front of the radical. Let's try another one. Let's find the square root of 300. So again, let's go over to a factor 3. I know that 3 must divide into this, so let's start by dividing by 3. And I get 3 times 100. I could continue going on my factor tree, or I realize that the square root of 100 is a perfect square root. So I'm going to rewrite the square root of 300 as square root of 100 times the square root of 3, which is simply 10 the square root of 3. And you've written this in the form k the square root of 3. For a fourth example, we're going to write these write in simplest radical form. So let's get our definition here. A radical is in simplest form when the number underneath the radical sign is the smallest integer possible. So we want to leave what's underneath the radical as small as possible and take out as much of the whole numbers as we can. So let's write the square root of 28 in simplest radical form. I like to do a factor tree because I want to see what numbers I can multiply together to equal 28. Now, you can do your factor tree of prime numbers, or you can pick perfect square numbers that you know will come out of the square root. For example, I know 4 will divide into 28. So that's what I'm going to start with. I know 4 times 7 is 28. So I'm going to rewrite this as square root of 7 times the square root of 4. And we know the square root of 4 is the same as 2. So in simplest radical form, the square root of 28 is equal to 2 the square root of 7. All right, we're going to write 125, the square root of 125 in simplest radical form. 125, well, I know 5 will go into this because it ends with a 5, and 5 happens to go 25 times. Well, 25, that's a perfect square root, so I'm going to stop there, and I'm going to rewrite 125 as the square root of 25 times 5, and I know the square root of 25 is 5, so that means my simplest radical form is 5 the square root of 5. All right, let's not be afraid of big numbers. Let's say I want to take the square root of 2,000. So I'm going to ask myself, what numbers multiply together to equal 2,000? Well, 2 times 1,000, or I could say 20 times 100. whichever way you want to look at it. So let's say I did 20 times 100. Well, 20 breaks down to 4 times 5, and 100 is a perfect square root, so I'm just going to keep it as 100. So let's see, that means I have the square root of 2,000 is equivalent to the square root of 100 times 4 times 5, which is equal to square root of 100 times by the square root of 4 times by the square root of 5. Square root of 100 is 10, times by the square root of 4, which is 2, times by the square root of 5, which does not break down. So that means I have 20 times the square root of 5.